Hey everybody, we're going to break down through to the other side of chemical reactions. That would be the product side, by doing all three of these things in this PowerPoint. Okay, so I want you to keep in mind that products are what comes from a chemical reaction. So make sure you read chapter 11, section 1, help yourself. All right, so how do you know a chemical change happens? Well, there could be an unexpected color change. If I mix something blue with something yellow, I would expect green. But if I mix two clear things and I see yellow, that's probably an unexpected color change. Other signs of chemical change. Heat's given off in a lot of chemical reactions. A precipitate forms. Remember that word, precipitate. A precipitate means a solid product from two solutions. Solid product. Make sure you know that. If a gas is produced from a chemical reaction, that could be a sign of chemical change. Or if an odor is produced, a different odor. Okay, so how do you know a chemical change happens? Well, you look for these signs. All right, one of them might not mean a chemical change. You might need more than one, or you might, some of these could actually be physical changes, but this is what you look for to decide if a chemical reaction has happened. Okay. So what's a chemical equation? It's an equation that uses the symbols to represent a chemical reaction. All right. So you might remember this one from biology. It's how plants make their own food. Okay. You get carbon dioxide and water, and then you get sugar and oxygen gas. Okay. There's a couple things missing from this equation, but these are the chemical symbols of the compounds or elements involved in the chemical reaction. All right, and so a chemical equation is a sentence, a chemical sentence that shows you how reactants turn into products. Okay. All right. So what are reactants and products? So the left side of the arrow are the reactants. Those are substances that are used up in a chemical reaction. There's starting material, reactants, starting material, substances used up. Products, substances that are made. Products, substances that are made in a chemical reaction. Remember, the arrow points to products. So that's how you can help yourself remember. So let's label them. Well, okay, here's the arrow. Arrow points to products. All right, and so these must be reactants. Make sure you can find those. I know, sounds simple, but now you got to remember it. Okay, so what other symbols are you going to see in a chemical reaction? You should write this table down. I know it's going to take a couple minutes, but you have to be able to translate. If you see a parentheses with a G, then you're thinking of a gas. If you see parentheses with an L, okay, L, then you're thinking of a liquid. Parentheses S is solid. Parentheses AQ is aqueous, which means dissolved in water. Okay. If you see a plus sign can mean either reacts with, if it's on the reactant side, okay, reactant side of the arrow, okay. It can also mean and. Right. A down arrow in a chemical reaction means a precipitate was produced. Hey, we just talked about a precipitate. It's a solid product, okay, a precipitate product, okay. If you see an up arrow, we use that to show a gas product. If you see an arrow in the chemical reaction, they're saying to produce or makes or creates, but the arrow points to products. Now, if you see an arrow, but there's something above the arrow, now it doesn't always have to be PT for platinum. It could also be a triangle for heat. Platinum. It could be another thing like Ki, which is a compound. Anything above an arrow is indicating a catalyst is used. Okay, and we'll explain catalyst as we go. All right, so hey, we can translate now. We can put this into words. So this is saying that calcium oxide. So I should say solid calcium oxide. Solid calcium oxide reacts with. Hey, that's plus sign. Solid calcium oxide reacts with hydrogen gas. Hey, why don't I call that anything else but hydrogen gas? Hydrogen's one of our diatomics, H2, so we just call it hydrogen. To produce, what part am I translating there? Arrow. To produce aqueous calcium hydroxide. All right, so all that stuff with naming and formula writing, you can you have to translate. So we could say solid calcium oxide reacts with, that's the plus sign, hydrogen gas to produce, that's the arrow, arrow, aqueous calcium hydroxide. Or we could say a solution of calcium, or a solution of calcium hydroxide. So there's different ways to translate it. On the next slide, we will translate this one in class. Okay, so be ready. All right, put the words into a chemical equation. So we have to be able to translate both ways. Hydrogen gas reacts with oxygen gas to produce gaseous water. Okay, so hydrogen gas. H, you're thinking hydrogen, H. You're thinking gas. And then you say to yourself, wait a second, remember, Nof, cool, Bree. Whoops, I put the I in the wrong place. Nof, cool, Bree. 1, 2, 3, 4, 5, 6, 7. Hydrogen's one of those, so you have to put a 2 next to it. Reacts with is a plus sign. Oxygen gas, O. And then you say to yourself, wait, O is the ah and Nof, cool, Bree. To produce, I'm thinking arrow, gaseous water. Well, water's H2O, and it's a gas. Now, we're going to learn how to do this in this video notes, but look, there's 1 oxygen here and 2 oxygen there. What the? So I'm going to put a 2 there, so I get 2 oxygens, and I'll put a 2 there. All right. Don't worry about the coefficients. We're going to learn those in a second. This is a translation of words into a chemical reaction. All right. We're going to translate this one in class, so be ready. All right. So, because chemists have been studying chemical reactions for a long, long time, this is a picture of someone thinking about chemistry. All right. So, there's a law of conservation of mass, that says matter cannot be created or destroyed in a chemical reaction. The mass of the reactants will be equal to the mass of the products. So, how can it be? Well, the same atoms that are in the reactants rearrange to make new bonds, but they still have to be there. Okay, so you can't lose or gain any mass in a chemical reaction. It all has to be there, which means the atoms that go in have to come out, but they might be bonded differently when you're done. So what does that mean? Okay, so say we have these 2 atoms and this big purple atom when we go into a chemical reaction. When you're done with the chemical reaction, you might have this big purple atom bonded to each of the green atoms, but notice there's 1, 2 of those, 1, 2 of those, 1 big purple, 1 big purple, happy. Okay, so the atoms on the left and the right are the same, they're just bonded differently. It has to be balanced. So every atom has to be on both sides. So this is C3H8. It's called propane. These are oxygen gas molecules. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 oxygen atoms over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 oxygen atoms over there. I didn't lose or gain any oxygen atoms. But notice these oxygen atoms are oxygen gas. These oxygen atoms are part of carbon dioxide. These oxygen atoms are part of water, but they're all still there. And then we have our 3 carbons, C, 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 but now they're all part of carbon dioxide. And then we have our 8 H's, but now they're all part of water molecules. So we have all the atoms on both sides. How can we do that? Well, we have to use, we have to look at the reactants and the products. Remember, left side is reactions. Woohoo, reactants. All right. Right side are products. Woohoo! Okay, and when we're done writing the correct symbols and formulas for every reactant and product, we have to make sure they're all there. So we have 1 iron on the react. So we have Fe and S in this reaction. If we look on this side, we have 1 iron, 1 sulfur. If we look on this side, even though it's iron 2 sulfide, new compound, it's still 1 iron and 1 sulfur. Okay. All right. So subscripts. How do you know how many atoms there are in an element or a compound? Use the subscripts. So C2 sub, there's 2 carbons, 1, 2, and H6, H, 1, 2, 3, 4, 5, 6. So C2 make H6 means 2 carbon atoms, 6 hydrogen atoms, but they're stuck together like that. Hey, that's a covalent compound. Yay, sharing electrons. All right, so we got to be able to count. CO2, how many carbon atoms? There's 1. How many oxygen atoms? There's 2. Okay. All right, so now we're going to count these. There's nitrogen, hydrogen, carbon, and oxygen in this compound. How many nitrogens? Looks like 1 there, right? But this parenthesis goes for everything. So there's actually 2 nitrogen atoms. How many oxygen atoms? 1, 2, 3. 3. Carbon atoms. Just 1, because there's a coefficient of 1 right there. I mean, I said coefficient, a subscript of 1 right there. How many oxygen atoms? Well, we already counted oxygen, so let's count again. 3. Which one did I forget to count? Hydrogen. All right, so let's go and check hydrogen. All right, 4 of them right there, 4 H's. But there's a 2 outside, so that multiplies it by 2, so there's actually 8 hydrogen atoms. Okay, potassium, 1, manganese, 1. Oxygen, 4. You have to be able to count atoms because we got to make sure that they're on both sides. So, what about a coefficient? Coefficient, you heard this word before in math. It's a multiplier, all right? It's a place in front of a compound or an element in a chemical equation. So if there's a 3 in front, then it means 3 of those things behind it, okay? So what does this mean? This means 2 H's bonded together. What does this mean? This means 2 Cl's bonded together. What does this mean? It means an H and a Cl bonded together. But this means that there's 2 of those. Okay, so this is the coefficient. Hey, is there a coefficient here and a coefficient here? You betcha, it's a 1. But we don't have to draw in ones because they're assumed. Okay, so coefficients are multipliers. You don't have to put in ones. So let's count again. All right, so we said that there was 1 carbon and 2 oxygen, but wait, 2 CO2s means CO2 and CO2. Now we have 2 of them. Okay, so if we don't have the coefficient, we have to draw them both. All right. So the coefficient means there's 2 carbons, and there's 2 times 2 is 4 oxygens. I do this again. I'm going to change that to hydrogen right now, right up front. Okay, so we said there were 2 nitrogen, but since there's a 3 in front, then there's actually 2 times 3 is 6 nitrogen. Now, if this bugs you, then just write this. And you're like, that's a lot of writing, Mrs. Harbin. And I say, it's okay to have a lot of writing. So now I could take the 3 away because I have 1, 2, 3 of them. All right, so let's count oxygen. 3, 6, 9 oxygen. Let's count carbon. 1, 2, 3 carbon. Let's count hydrogen. 4, 8, 12. But let's do this again. There's 2 times 4 is 8, and that one 8. 8, 16, 24. That's a lot of hydrogen. Okay, or you can do 4 times 2 is 8. 8 times the coefficient of 3. Oh, get that out of there. 8 times 3 equals 24. Okay, potassium, 6K. That's a lot. 6 Mns. 4 times 6 is 24 oxygen. All right, we have to be able to count atoms. So balance these equations and show atom inventory. All right, so I like to write down what I have. I have H's and O's in this. When I first start, I have 2 H's and 2 O's, 2 H's, 1 O. That's not right. I need more O's. So I put a 2 in front of there, and I cross that out because this isn't true anymore. I cross that out. So I say 2 times 2 is 4 H's on that side. 2 times 1 is 2 oxygen. Wait, now it's not even. I need more hydrogen on this side. I'm going to put a 2 there, so I have to cross this out because I changed it. 2 times 2 is 4. 4 H's, 2 O's, balanced. Okay, try the next one, and we'll do it in class. So don't forget about your Knock-Cooper. All right, they always pair up if they're in a chemical reaction. Those are always gases, except bromine's a liquid. So we could put G, 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 L, solid G. G, 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 L, S, G for the states of matter when they're diatomic. Okay, so another way to find them is find number 7 on your periodic table, make a 7, point to hydrogen. Woohoo! Okay. All right, so here's to review. Chemical reaction is a sentence. All right, you can write a word sentence or a symbol sentence to represent a chemical reaction. The numbers in front of chemical symbols are called coefficients. The reactants are on the left of the arrow, and the products are on the right of the arrow. Remember, point to products. Point to products. Point to products. All right, subscript tells you how many of that atom. All right. And then we would put in states of matter. Hydrogen's a gas, oxygen's a gas, water can be a gas if it's pretty hot. There's solids, there's liquids. To produce, you gotta be able to translate. Lots of fun going on. And so just make sure that you understand this so that you can do chemical reactions. All right. Read chapter 11, section 1. All right. Can you do all this? I hope so. Peace out.